So today we're going to look at the ultrasonic distance sensor. So we have two different ones. We have one here with a three connection, which is the 5 volt in, the ground, and then the signal wire. This one has 4 different connections right here, and we can see what they are. The VCC is their 5 volt current in. Ground is going to be returning back. And then this is the trigger and echo. So that's the difference in between those two. So it's a trigger, which is going to cause the signal to send, and then an echo is receiving the signal back. Okay. So when we start this simulation, we're going to be able to click on these, and we should see a range, and you'll see that it's designating a distance to the pin via a triangle. Okay. And we can adjust that out further. Okay. And we can see that it's basing it off of the distance away is how strong that is. So as we go further out, we see the LED pin fade. Okay, and if we go outside of that range, it should completely disappear. Maybe it has to be out over the side. Okay. Well, it should disappear. Okay. Okay. So we're going to hit here, and it should be the same. So closer should fill up all 3. Further away should only have the 2 or 1. So it's kind of in that mid-range is going to be 2. Okay. And then outside should be none. So we got to look at the code to figure out why it's showing as 1. Okay. And once again, these are showing up as vertical. They're showing up above it. Reality is this would be shooting out, so this face would be coming out towards us. Okay. Any questions so far? Okay. So now we're going to go through the build process. The build process, we're going to follow these instructions over here. You see that we're going to set up the LEDs first. Okay. So we're going to get our board. We need our breadboard to plug things into. We need a handful of LEDs. Now the trick that I showed yesterday was once you have it selected and you know it's selected, you hit Control C and then Control V, and it'll place multiple ones. Okay, so we need the 3 LEDs, and then we need resistors. I'm actually going to drop that one or get rid of that one for right now. Okay, because what we're going to want to do is we're going to want to set it to the resistor size that we need, which is 220. Okay, so we're going to set this and go 220 ohm. Then we're going to go Control C, Control V, and just place multiple copies of it. Okay. And then what we're looking at doing is we're just placing those in. The location on the breadboard doesn't really matter as much, as long as we have space for everything else to come in. Okay. And remember, the anode is the positive side, so it needs to be receiving the signal. The cathode is the negative side, so it's returning to the black. Okay, so we're going to put that in. We're going to place those in. Okay. Okay. And now we're going to connect our positive, our 5 volt, and grounds. So our ground, we're going to swing over, swing out, swing up, and place, swing over, swing up, and place. And I'm going to change those. So positive, we're going to change to red. Negative, we're going to go black. Okay. And you can do a little cleanup if you want. It's not something necessary. As long as you don't have wires like trailing all over the place, we're pretty good. Okay. So we're going to start with our first signal wire over here, going into 2, 3, and then 4. So we're going to feed out and go up. We're going to feed out and go up. These wires don't matter their color. Okay. What does matter is their placement for where they fall here and then where they fall at within our channel. Okay. Okay, so we got that all set up. Now we're going to we're going to set up our readers. Now they're saying, okay, set up 2 boards. What we're actually going to do is we're going to try to do 1 board, not for both, but we should be able to switch them out. Okay. So we see the 1 ultrasonic board. Okay. And we're going to have to go and find the second ultrasonic board. Mary Grace, leave it alone. Okay. So we're going to take and place our 3-pin. Okay. Now if we did want to, we could use both and then make a switch to determine which one we are actually reading to. And how that switch would work is we could bring in this slide switch and we'd run our terminal to the 5 volt and we could bring 5 volt up in through the middle. So this would be red. We could leave green going over there. Our black goes to ground. And then our signal, pending on which one they use as signal. So it looks like the first one they're using 7 and the second one they're using 7 and 6. So this first one, our 3-pin, we could set up to using 8 and then 7 and 6 also. Okay. I know I'm kind of doing a lot in this single board, but it's okay. Yeah, so this is going to be our power. So we're going to rotate. Oh. We're going to bring that up. We're going to send our ground down to ground. Okay. And we're going to send our signal for this first one to 8. And we're going to set that to probably white. Okay. And then our trigger we'll set to brown. I'm going to feed this one out over here and come around. We're going to go brown and gray. Okay, so this, mind you, once again, you don't have to worry about this. What this will do is when we do run the simulation, we'll be able to select which one we want to run from. Okay, so we have both set up currently. Okay, so now we got to do our code. Okay, so this is our code for the project. So there's a comment up above. So set distance threshold to 350. So we're going to set on centimeter to and then ultrasonic pin. So that's the trigger, and then echo. So the same as trigger, and then in units centimeters. So that's how many centimeters away it's reading. Okay, so this is for the 4-pin one, not the 3-pin one. Okay. Okay. So we're going to go into code. We're going to bring that away. Okay. So the first one that we're looking at is we're going to get a couple variables in. So we'll saw the variable. Distance threshold is what we're going to be using. We can also follow along right here. So click code, make sure the notation, click variables. We're going to create a new variable called distance. Another good name for this, you could just go D threshold. You can hear my little one in the background. Okay. Okay. And so you'll notice that this is one of them that's not actually initialized to 0. Okay. So we want to initialize this as 350. So what that should be is the distance away that it's reading. Okay. Okay. So to store the centimeter value, create a variable called cm. Okay. Drag out a block and set block. Distance down. Distance. Adjust the drop down to our new variable. Okay. Oh, it's in variables. Okay. In the input category, drag out read ultrasonic distance sensor on block and place it inside the set block. So we're going to place it right there. So we're going to input category, read ultrasonic distance. Okay. Okay. So we have distance set. So adjust the drop-down menus inside the input block to set the trigger pin to 7. So this one should be 7. And then echo pin, same as trigger. Okay. We could actually change that. So they're using just as the 1. So it's just sending out and reading them as the same. Okay. We could use a block to convert. Okay. So we could take this and we'd go variable inch. Okay. And we'd go set inches to math. And we'd go cm times 2.54. So that's going to set our inches to equal our centimeters. Okay. Oh, centimeters, not times. Divide. Okay. So we're going to add some serial monitoring blocks to print out the sensor distance in centimeters and inches. So we're going to go output, serial monitor. We're actually going to add a couple of them. Actually, let's see if we can do this. So we're going to add this to there. We're going to go CM. Oh, it won't let us do that. Weird. Oh, there it goes. We go space. Oh, it's not letting us do that part, though. Dang. Okay. That's fine. So we just have to go back and do that the harder way. We're going to change this to without. And we're going to go space. Sorry. CM space. You can go comma space or space. Okay. And we're going to go without. We're going to go inches without. And then we're going to go here. We're going to go IN, no space, and then with our new line. So what that'll do is that'll output our inches in centimeters. Okay. So now we're going to go to the variable category. Okay. Oh. So Okay, so we're going to go control. We're going to go drag out an if. It just wants an if then. Okay. And we're going to drag out to the math. And we're going to pull out a comparator block. Okay. So we're going to see if CM is greater than distance threshold. Okay. So this is going to set right there. So we're going to go if CM is greater than distance threshold. Okay. And add 3 digital outputs blocks inside and set the pins to 2, 3, and 4 on low. Okay. So we're going to set. We're going to change those to 2, 3, and 4. And these are going to read low, low, and low. Okay. Let's see. So we're going to duplicate this, and then we're going to set the threshold minus 100, and then minus 250 to get, okay. So we're going to go here, we're going to go here, and we're going to go math. So the distance is farther out than our threshold, so no LED light ups should happen. Okay, so remember our threshold's 350. Okay, so if it's outside of that, nothing should light up. Okay. So now the next setup is we're going to basically take this and we're going to go, okay, comparator for this. And we're going to go CM is our distance threshold. And instead of plus, we're going to minus 100. Okay. And what that's going to do is that's going to turn on we're going to have that turn on just one of them. So what we're going to set is we're going to set 2 of those to low. And we're going to set 2 to high. So that's going to show 1. Okay. So we're going to set that should be greater than or equal to. So you can read that based off of closer than or equal to the distance threshold. Okay. So we can go check that up here. Okay, so they have an and statement in there. So CM is less than or equal to the distance threshold, and CM is greater than distance threshold minus 100. Okay, so we have one side of it set up. Okay, so we're going to go grab our comparator statement. Okay, and we're going to plug this into that half, and now we got to go make sure. So we're switching that to greater, and we got to go make sure that it's less than the distance threshold. So we're going to go grab our comparator block. We're going to go CM is less than the distance threshold. So what this and statement means here is this part right here. This first part, CM is less than distance threshold, less than or equal to. And this both have to be true in order to flow into this area. Okay. So I'm going to get another one out because I know I'm going to need at least 2 more. Okay. And we're going to set up basically this same setup right here. But we're going to go, okay, if it's less than or equal to distance threshold minus 100 and CM is greater than distance threshold minus 200 or 250. I don't remember if it's 250. Okay, so we can see 250 and then 350. Okay, and then they have a fourth one down here for greater than or equal to distance threshold minus 350. Okay, so we'll drag that last one in. Okay. So now we're going to go get our comparator block with our and we're going to throw that into those two. And we're going to place that one there because that one's just going to be set up for if it's all closer to us. Okay. But now we're going to build this side. Okay. So we know we're going to need this. And we're going to need to pull a plus statement in there or minus statement in there because we're going to go in between that and minus 100. And we're going to go CM. And so we can throw that in. And it's going to be distance threshold minus 250 with CM not 1. Okay. Oop. Okay. So that's setting up that range. And so our output is going to be between these. And so if that first one had 1 set to high, this one should have 2 set to high. And we're going to go low, low, low. Okay. So this will read 2 high and then 1 low. Okay. So now our last statement's going to be is instead of this saying 100, we're going to do 250. Okay. We're going to go CM is less than distance threshold minus 250 and CM is distance threshold greater than. So these should be less than or equal to. This is greater than distance threshold minus 350. Okay. So our output should look like set pin to high. So this is going to set all 3 to high. So 2, 3, and 4. Okay. Now our last statement is just going to basically pull this one. Basically anything that's close or right on top, we're going to have it light up. But what we might do is we might change this to doing our pattern that we created to where it counts up and counts down. Okay. Okay, so we're going to go CM is greater than or equal to our distance threshold. Oh, forgot to put our other block in there. Our distance threshold minus 350. Okay. So we're going to drag our blocks in there. Okay. We're going to use the control. We're going to throw 1 at the bottom. Okay. We're going to have this as 0.1. 0.1, 0.1, 0.1, 0.1. We're going to throw another 0.1 down at the bottom. These bottom ones are going to be low, 2, low 3, and low 4. This one's going to be high 2. We'll go 4, 3, 2. Okay, so that should be anything that's closer than us. Okay. So now if we start, okay, we change this so we're reading from this board. Okay. So we notice we're really close. Okay. So we might not have set our range right for this. Okay. So we might have some setup that we need to do there with that. Okay. Yeah, so we should have that. It should be working, but for some reason it's reading really short. So I think our overall distance is set up a little bit wrong on it. But code-wise, it looks right outside of this. This, I mean, if we were to take these and we were to get rid of them, okay, or we throw them out here and those just always set to low. Should be what we have there. Okay. So we're going to run through and check really quick. Just to make sure. So we can compare that. Okay, distance threshold 350. Okay, set to cm, read, echo. There we go. Okay. Set inches to cm divided by. Good. Okay, without, with. Okay. We go cm is greater than distance threshold. Okay. Cm is less than or equal to distance threshold, and that should be all set up, right? So that's set up right. That's set up right. Mm-hmm. Mm-hmm. Oh. Yep, leave my orange there. So I do see one that I have set up wrong. It's this very ending piece right here. Mary Grace, I can do that once when I'm done teaching, okay? Okay. Okay, so we're going to see if that's what messed us up. So those should be lighting up right now. Based off everything else that we do have. Those should be, well, they might not be lighting up actually right now. Because those might be turning it off way too fast. Yeah, see, those should be lighting up. But I do notice that our distance, no, our distance is reading, right? Our distance is a little short. Yep, there it goes. So we have our lights blinking. Now remember, we don't have a way to turn them back off. So we're going to check. So that should drop them. Should drop them as it goes out. But I'm wondering if we might have an error over there. But it's okay. We saw that it works. We got it going. Okay. So what they have as a task is, could we make a proximity alarm by adding a piezo buzzer that turns on when all 3 LEDs are lit up? Okay. How do you think we could create that with this setup right here? Okay. I'm going to challenge you guys to think about that. We'll talk about it tomorrow on Friday. And then I'm going to get my setup going for us to do the circuits live. So we should hopefully get this working out and everything set up. Does that sound good? All right. We will see you guys on Friday. Have fun. Stay safe.